Well, hello again, everyone. I'm Ruth Jones with the Office of Alumni Engagement here at Mines, and welcome to our September Lunch Bunch. We are excited to be continuing with our fall lineup of programs that celebrate the people that make Mines great. There's lots going on here, and we're so glad that you've taken the time to learn more. As always, if this is your first lunch bunch, thanks for logging on and welcome. If you are a returning lunch buncher and you all know who you are, raise your hands. Thank you for your continued support. We always love seeing familiar faces each month. This month, we are thrilled to welcome Dr. Stefanie Tompkins, Mine's new provost, to the program. Some of you may remember Dr. Tompkins' name from years past when she served as the director of our Research and Technology Transfer Program. So she is certainly no stranger to Mines, but she now has a new role, much of which includes shaping our faculty, our student and academic programs, and more so that Mines can continue to excel in our mission of producing the talent, the knowledge, and the amazing innovations that industry and society need, which we're really good at delivering. So we'll hear from her in just a minute, but as we get started, a few quick reminders as always. If you've got a question, please feel free to use the chat or chime in, use the little hand raise button. And Dr. Tompkins, I think you're okay with taking questions throughout the presentation, yeah?
Yeah,
Okay, so
absolutely.
we'll just address those as we go. Great. And many of you already know this, but all of our programs are recorded and can be accessed on the Lunch Bunch page of our alumni website at weare.mines.edu. It's the same page where you came to register for today's program. At the bottom of that page, you'll see buttons for each year's recordings. So, if you missed one, you want to listen to another program, or you want to listen to this one again, or share with a friend, you can visit that page to access the complete archive of all the recordings that now go back, my goodness, 5 years. We got a lot in there, so it's kind of fun to check those out. Always a shout to here about ideas for future speakers, or there's a program that you want to know more about. Please tell me. I mean, the majority of the are from you want to deliver the Dr. Stefanie Tompkins to Lunch Bunch. Take it away.
Oh, thank you, Ruth. Good afternoon, everybody. Or I don't know, late afternoon, late morning, depending on where you're calling for me to. I hope by the time you will understand how sincere I am in saying that I could not be happier to be back at Mines, which I think is one of the most extraordinary places on this planet. So I wanted to do a few things today, and to keep within the spirit of what the foundation promised in terms of what I was going to talk about. And I know it was mentioned that I talk a little bit about my journey from a place called DARPA to the Mines Provost position, and what that entails. So I'm going to start by actually explaining the Provost job itself. And I will caveat that by saying I've been in it for 4 months. And for a lot of obvious reasons that will become obvious, I'm a very non-traditional choice for this role, which means that I am still learning and I'm still uncovering little hidden corners of what the job actually entails. But I think I've got my arms around most of it, and it's a pretty exciting time to be here. So I'm going to talk about what a provost is and what we do. I'm going to talk about how I got here. And then I'll talk about a few things that we're actually working on here at Mines, some of which you've heard of, some of which you might be able to guess. And then for everything I talk about, there's probably 50 other things that we won't have time for, but I hope you pull some of those out with the kinds of questions that you ask. So if we start off by just asking ourselves what a provost does. Hang on, I gotta wake up my computer. There we go. at the simplest level, you can think of it as being the vice president for academic affairs, so academics. And that means the professors, the classes, the material that they actually teach, and all of the degree programs, promotion and tenure for the professors, and all of the things that sort of go along with that. So anything to do with curriculum, with grading, with courses, that falls under academics and under the provost's office. However, we never work in isolation. So in very close partnership, oops, I have my colleagues, the vice president for student life, and the vice president for technology transfer, Walt Copan, and Ruth, you saw that you over on the right a number of years ago. And so student life, we're right? It is everything about students that is not directly related to academics and classes. And as you can see, there's overlap. So for example, we share a lot of advising and mentoring duties. We share a lot of tutoring. Both of us have our hands in some of the special honors and scholars programs. And we are constantly talking about how we can better, by using our combined forces, how we can strengthen the support that we provide to students. And then over on the right, you have research and tech transfer. That is, at some level, it is a whole series of enterprise level efforts. So these are our laboratories, these are our research centers, like our amazing Steele Center, which has been fully self-reliant, unlike most university research centers, for well over 35 years, and it's just an extraordinary national and international resource. But in addition to managing that enterprise level research, Walt's team also, directly connects with the faculty whose job requirements frequently require that they do research, right? And so we intersect in that space where I am responsible for the faculty themselves and for their performance, and then Walt helps provide them with the resources and provides a lot of the support and the big picture initiatives that help drive our research forward. I think maybe it's worth a second to talk about, kind of my philosophy on the mission of a public research university. And that is that, our job is to create and expand knowledge, for the betterment of society and for industry, and then to transfer that knowledge out. And that knowledge is done through the students who we're preparing, to be these amazing engineers and scientists who are going to change the world, but to also arm them with the fact that the knowledge base changes constantly, and that knowledge is being created and changed literally by the professors that are teaching them, and hopefully by themselves as well, as we pull them more and more into research projects that they get to be part of. So I think I sort of said this, but just to illustrate it, if you look at these three circles, the students typically see that left hand 2/3 of it, and then the faculty are mostly going to concentrate on the right hand side of it. And I get the immense fun of living at the intersection of all of that. And so, as I said, it's been 4 months in. I committed to trying to meet with all of our faculty during the summer. I failed. I did get to meet about 230 of them, which they tell me isn't bad. They thought I wasn't going to get anywhere near that, but it does mean I have at least 100 to go, and I am still plugging away, and I'm looking forward to hearing from all of them. Okay, so now hopefully we're all somewhat comfortable with what the job title of provost is. I know it's not one that most students pay any attention to, nor should they. If I'm doing my job well, they don't likely need to know, because it means things are running smoothly. But let's talk a little bit about how I got here. I did mention that I am not traditional, a choice for provost. Almost always a university provost is someone who would previously have been a dean. A dean is typically looking over a large portfolio of departments. They might be the head of a college or a school within a larger university, and they themselves would have typically been a department head and a professor. I have never been a professor. While I have only taught, small scale as for example, as a graduate student or kind of on the side. And I don't know what it is like to go through promotion and tenure. And so it's been an interesting journey. It's very rare that I would take on a job where I haven't lived the experience thoroughly. And I'll talk to you a little bit as we go forward about why I was both encouraged to take it and why I think that I can make a difference. So we'll start off. After college, my first job was in the United States Army as a military intelligence officer. And I will say, and I'm a little embarrassed, I work with our students all the time in explaining how important it is that they take advantage of career services. I did not do that. I was on an ROTC scholarship. I knew from day one that I had a 4-year minimum job in the Army, and thus I ignored everything and just enjoyed myself. But I served in the Army, served in a few places around the world. Mostly what I got out of that was tremendous leadership experience. My very first job was as a platoon leader with 40 bright young soldiers, all working technical equipment. So that then led me, with a small pit stop along the way, to go into industry for a decade. And I worked for a company called SAIC, Science Applications International Corporation. In the little pit stop along the way was 5 years of graduate school where I got a degree in geology and spent a little time working for a small company on the side in order to help pay the bills. So the company I worked for was a very fascinating decentralized company that had profit and loss centers all over the place. I started off as a scientist, worked my way up to leading one of the P&L units. And somewhere in the last year or so of that decade that I was there, the CEO, the founder and president of the company retired. And they brought in new leadership, and the new leadership said, we can't do this decentralized model. We're going to behave like a real company. They centralized everything, and I decided that wasn't the business model I wanted to be part of. So I went hunting for a place that also had that more entrepreneurial, choose your own journey spirit. And I ended up at this very unusual government agency called DARPA. So I'm guessing a lot of people here don't know what DARPA is. It stands for Defense Advanced Research Projects Agency. And if you want the really kind of glib description of what DARPA is, it is the place that will say you're welcome if you ever want to thank somebody for the internet or for self-driving cars or mRNA vaccines or stealth aircraft for those of the folks that are in the military, and hundreds of other things. DARPA is the high-risk, high-payoff arm of the Department of Defense. And essentially, they take all of the technology risks that the rest of the government doesn't feel comfortable doing. So if something is likely to crash and burn, DARPA is more than willing to be the one to take it on and handle the fact that, in fact, the project might fail. But at the same time, many of those projects don't fail, and they end up having outsized impact, not just on the government, but on society. So while I was at DARPA, I served as a program manager, which means I created a lot of technology programs, particularly in the area of navigation and timing, which connected back to my geological roots of understanding things like maps and geodesy. And then I ended up, at DARPA, typically we tell everybody that you only have enough time to get comfortable before we kick you out. DARPA has a $4.5 billion budget. Your job is to change the world, and the only way you're going to change the world is with a sense of urgency. And that urgency comes from the fact that you're going to get kicked out somewhere around the 4 or 5 year mark. So I did 5 years as a program manager, was ready to leave, and they pulled me back in and asked me to take on another 5-year tour as a leader. And so I ended up leading a couple of offices in leadership roles for a couple of different offices. While I was there in that office leadership role, I had the bulk of DARPA's budget that focused on universities. And so I spent my time traveling around the country and actually around the world, visiting many universities, immersing myself in understanding how they were incentivized to do research and technology development, how they worked, what their strengths and weaknesses were. And I had a fantastic time, but I will tell you, I walked away from that with the absolute conviction that I did not want to work for a university. Until one day, about 6 months before I was wrapping up that second 5-year tour, I was having lunch with a friend of mine, and she mentioned that the Colorado School of Mines was looking for a vice president for research. And I immediately, my brain snapped in to say, well, except for the Colorado School of Mines, of course, because if they ever would have me, I would love to go. This is the geologist in me, which is to say that I had always known since my undergrad years that this was the place I would always like to one day have a chance to be part of. So the journey took me to Colorado School of Mines. I was in it for the long haul. I was really excited. I believe I was making a difference. We did some pretty extraordinary things while I was there, including increasing our research volume by over 50%. Those of you who have heard about mines being designated an R1 institution, that designation came right after I left. But unfortunately, I did leave. And I left because I got a call from the federal government and from the last administration asking if I would serve as the director of DARPA. I am, just for everyone's general knowledge, I am an independent. I had always assumed I would never be called to a position because I am an independent. It does turn out that in the Department of Defense, typically, they ignore such things, and that was a wonderful thing to learn. I loved my time at DARPA, and I felt like I had to give back to the country. This was in the tail end of COVID. A lot of people were suffering. A lot of people had made significant sacrifices. The fact that my husband and I were going to have to spend 4 years living in different states felt like a tremendous sacrifice, but it felt like it was embarrassing to even think that we would be so selfish as not to make that, considering what everyone else had gone through. So we took that on. I moved and got a tiny little apartment in the Washington, D.C. area. My husband and our cat maintained the homestead back in Arvada. And I wrapped up 4 years at DARPA this past January. Towards the very tail end of that, I got a phone call from some folks back at Mines just saying they thought it would be useful for me to know that they were opening up a search for the provost position. And they were wondering if I might be interested in applying. And my immediate reaction was, I am completely unqualified. I have never been a professor. I have never done all of the things. I'm going to manage people whose jobs I have never had experience. And what they ultimately ended up convincing me was that this career I've had in the intersection of science, public service, and with a significant amount of leadership in the people and science and technology domain might be what Mines needed at this particular moment in time. And this particular moment in time is, in fact, a time of great change. So DARPA, sorry, I forgot to click through. In the end, I did compete for the role and was thrilled to be selected and started this past May, basically the Monday after commencement. And I have been on an extensive learning curve ever since. The days go from sort of 6 in the morning to 9 o'clock at night. I am meeting with all those faculty that I promised to. I am unearthing all kinds of complex intersections of how universities really work. And one of the things that we're dealing with is simply the fact that Mines has grown so successfully, but so quickly in the last few years that we're almost operating the way a startup company might when they've quadrupled in size, but they're still functioning the way they did when they only had a handful of people. We are dealing with the fact that a lot of our business processes have been are operating they were when we were half our size. And so this is where all of this other experience that you see on this chart sort of comes into play. But lots to do and lots of opportunities. So I said, now that you've got a little context of how I'm here, we'll talk about highlighting some of the things that you might have heard about that we're working on, maybe some things that you haven't, and I'm happy to talk about anything you have questions on. But here's what's top of mind when I think about really big things that pull together all of the academics, but certainly all of the university as well. I understand you had a great talk on quantum engineering. I'm guessing that was by Professor Sarrazin, by Fred Sarrazin. So I'm not going to try to explain quantum, but I am going to highlight a point that I think sometimes we don't emphasize enough, and that is that we are talking about quantum engineering. In the world of quantum physicists and quantum scientists, there still remains incredible debate about exactly where things like quantum computing are going to end up. There is still deep discomfort among a lot of people about the fundamental laws and how quantum science behaves. It kind of hurts everybody's head. Einstein had issues with it, and there are people to this day who do. But engineers only need to understand how a system works, and they need to know that the rules are predictable and repeatable in order to figure out how to put them to use for the betterment of the rest of the world. We are focusing on that quantum engineering mode, which is to say that you don't have to be a Nobel Prize winning physicist to participate in quantum. You actually just need to understand how to apply the rules just the same way you would to apply Newtonian laws or the laws of thermodynamics in order to build an engine. That's how we're thinking about quantum engineering. And we had one of the country's, probably one of the world's first quantum engineering graduate programs. And I will say we're thinking pretty hard about expanding that and what that might look like if we think about that for undergraduates. Shouldn't come as a surprise to anybody that Mines is in the center of a lot of conversations around critical minerals. But by the way, one thing I should say is if you are walking through the Washington, D.C. area or paying attention to what's being talked about in the United States government, there are sort of four things that come back over and over and over again. Quantum, critical minerals, energy, and AI. And three of those, the first three of those are things that Mines is just expert at and has been and will continue to be. And critical minerals is one of my favorites. What I will say is that my time at Mines as vice president for research and what I learned about the full supply chain from discovery to extraction and processing and in through the many, many different technological streams that critical minerals and just raw materials in general end up going into, hugely informed what I did when I was the DARPA director. And while I was there, significant chunks of our investment were focused on supply chains and on trying to shore up what we thought was a huge vulnerability in national security. And that was because of what Mines faculty taught me and a lot of our alumni and industry partners. So I thank you for that. And the nation may not know it, but they should thank you for that as well. All right, energy I could talk about all day, obviously. The hardest thing to say when we talk about energy at Mines is that it is so pervasive in what we do that it's really hard sometimes to pin down themes, right? There is, other than probably coal, there is very little in the energy space that we don't have a really significant role in, whether with obviously petroleum and geothermal and geologic hydrogen and solar and wind and nuclear. So all of those areas are areas where if you look at the full research across the span of what Mines does, I would say, at least 80% of what we do connects in some way, whether it's directly working on the energy systems, whether it's working on the raw materials, whether it's working on sort of materials engineering to create the new materials that we need for the new systems. All of that just kind of interconnects in ways that are fascinating. Okay, so entrepreneurship and innovation. So E&I does stand for entrepreneurship and innovation, but I thought I would replace that just for now with entrepreneurship and ideas to reality, because this ideas to reality concept is something we're talking about more and more and more, and it lives at the intersection of all of those bubbles I showed you at the beginning. Student life, research, technology transfer, commercialization, and academic affairs. And that is about making sure that every one of our students, regardless of whether they think of themselves as being entrepreneurial or not, develops the kind of the mindset that if they have an idea, they can take that to reality, and they should have all of the tools and the skills that they need to be able to do so. And we want our students to have multiple experiences throughout their time here in turning ideas into reality. Some of those realities might end up being entrepreneurship in the more traditional sense of a startup company. We have obviously quite a few student startup companies, but it also could just be things related to how they approach their senior design projects, how they approach a whole variety of other just problem-solving opportunities that they have throughout their time here at Mines. And then the last thing I'm going to highlight, because it would be sort of silly to pretend it's not happening, is that we live in a very, very dynamic world for multiple reasons. Obviously, geopolitics are more dynamic than they have been in quite a while recently. But there is an overprint on all of that, which is this technology revolution that large scale machine learning is imposing upon society, right? So it's affecting workforce, it's affecting how different companies are thinking about what they're hiring for, changing entire industries and technical fields. And it's certainly changing how we teach, what we want our students to be proficient at, how we balance what they absolutely need to know themselves and what they need to be really good at partnering with a machine to do. Um, just so you know, I mean, fun, right? Just when we think we have our arms around it, a new iteration of, say, ChatGPT or Google Gemini comes out, and then we have to rethink some of it and keep going. So we're working really hard on getting ahead and making sure that our students are prepared to be fully proficient with whatever AI actually ends up being, and proficient throughout the entire journey as they go. And then that last little bullet with all the dots is just meant to highlight the fact that there are pages and pages and pages of other things that are going on all of the time. I figured if something takes longer for me to explain before I tell you what it is, it was probably not a good candidate for talking about today. But there's quite a lot to do, and I think there's amazing opportunity right now for us to think about the role of research and universities and commercialization and all of these technology areas as they come together in what Minds is able to deliver to the world. And that is both with our graduates and with the products of our research. And so with that, I will stop talking, and I am happy to take questions. And I already know if anybody doesn't feel like being the one to break the ice, Ruth is prepared with a question or two.
I've always got questions, but I'd rather hear from folks on the call. So, yeah. Anybody have a question for Dr. Tompkins?
Yes, this is Chuck Schultz.
Hi, Chuck.
Hello.
Ruth, I have a question for the doctor on the quantum engineering, and that is a concern about how many parties are involved in that, and how do you herd that many cats? Do we have the right management structure to ensure that we manage the project correctly?
Yeah, that's a great question. I will say we have a lot of the right talent and parties. The management structure is continuing to evolve, and that and so first of all, we actually have we are likely to be hiring more quantum experts soon, and they will be across multiple departments, where this is something we're thinking about really hard. This is not just physics, but it also involves computer science and electrical engineering, for example. But really the structure, because it's inherently multidisciplinary and it just crosses all of those different departments, is exactly something where we're sort of experimenting with and evolving the management structure as we go. So we don't believe that business as usual and how we arrange things at a university is going to work really well. So I don't have the final answer to your question, but I can tell you we're very aware that it's an important question.
Thank you.
I do see a question in the chat from Kelly Olson. Kelly, would you like me just to read the question? Can everybody see that, or would you like to read it?
I can come off mute.
That would be great. Thank
Hi,
you.
Dr.
Welcome.
Tompkins. Always good to see you.
Yeah.
Appreciated the overview. I had a little bit of history of your background, but always good to hear it directly from the source, and I learned quite a bit. But was curious about the roadshows that you're doing right now with faculty. I'm quite impressed by the number that you've been able to get done in such a short amount of time. But what are some of the themes that are emerging from those conversations that might be shaping how you are viewing your first year in the position?
Yeah, that's a great question. And I will tell you that I have a town hall with our faculty coming up next week, and the whole topic is that. So I am in the process right now of synthesizing all of my notes from all of those conversations with the 230-ish faculty members, and organizing them. And what I owe them is what I have heard and what I am doing about it. But some overarching theme, one is just how much they love the collaborative spirit and the energy of a place like Minds. They this is the place they want to be, and they are tied to it. Many of them are tied to it in a way that a lot of university faculty aren't typically tied to their university. So, in a lot of cases, it is really much, it is a professor, their research group, and then the university is sort of simply the shell that provides the support structure that allows them to operate. And at Mines, there is a much stronger sense of connection to the university, collaborative spirit and support with their fellow faculty members, and just a really deep love of students. I think the quality of our students makes that really easy. The size of the university, it's not too big. It's big enough to have, resources to do bigger things than any one person can do, but it's not so big that people can't actually all know each other. So that's something I hear. I also hear that people are very tired. There's a lot going on, with all of the growth that has happened, so much change. We're grateful that we are sort of stabilizing, and we're at the period that President Johnson sort of designed the university to be. So this is the second freshman class in a row that's sort of the same size. And so we're leveling off. And that means that instead of behaving like a startup that is sort of changing and constantly, we now have a chance to look at how we do business and make ourselves more efficient, more effective, and not have people stretched quite so thin. There's certainly concern about some of the issues, in terms of what's happening right now with respect to the federal government and universities and research. So we're working through a whole variety of scenarios of how to help faculty with that. There's a lot of excitement about these themes that we've been talking about, things like critical minerals and energy, where faculty see and bring forward opportunities. Lots of questions about undergraduate majors and this shift over the last many years with more and more and more focus towards mechanical and less focus on some of the things that we're traditionally so well known for. And so part of what I've been doing is trying to unearth whether or not we've created some hidden curriculum barriers or things like that. And so we're actually pretty excited about what the opportunity space in that area looks like. It's just lots of things like that, Kelly. So it's a range of big picture themes, and then probably 100 or more interconnected smaller problems. And a lot of what I'm dealing with is not trying to tackle what seems like a small problem and then unintentionally having an impact on all of the other small problems that might be connected to form like a bigger problem. So that's the gist of it, and we will be reporting out more broadly on all the things that we're hearing after I have my town hall.
I have a comment rather than a question, maybe. Dr. Tompkins, number one, I'm familiar with DARPA over a long period of time. I touched it more often than I didn't get burned, but I touched it a number of times. And I think what you'll bring to Mines is really a good thing, because that's a challenge to use your knowledge in ways that have a purpose, and you have that purpose before you start. I was very positive to see in your slide that you used a term called ideas to reality. And I'm not really familiar with that as a term of art, but going back a few decades, when you graduated from the Colorado School of Mines, you got a job for one reason. People actually believed you could do something. They weren't hiring you to learn or think about or whatever. They wanted you to do a job. And that was a tradition that I think has continued. And I hope ideas to reality at least has an ingredient that looks kind of like, what are you going to do with it type of questions and everything else, because that's what really gets people's job. That's what gets you success. That what's make you feel good in doing your work. So I thank you. I'm very glad to see you here as provost. I think that's a great idea, and hope you'll be able to influence some of the attitude, not just the academics of Mines. So look forward to it.
Yeah, thank you very much. And you're absolutely correct. That is exactly what that ideas to reality spirit embodies. It's about making sure that people understand what all the resources are now in this world where technology gives you more and more sort of tools to use when you're helping to move the idea into reality. Yeah. So I know there are more questions in the chat.
I do. I see a question from Ty Lewis. Ty, if you want to unmute and ask the question live, that would be lovely, or else I can read it, whichever you are most comfortable. Are you still with us? I'm not sure. I'll go ahead and read the question so everybody can hear it if you can't see it, but
Ty says Ty is here.
oh,
Maybe having issues with the audio.
okay. Okay, well, Ty's question is, how are you aiming to address with the students the impact of AI on hiring, especially recent grads?
Yeah.
So that's a big question. That's a big
It's a
one.
really big question, right?
Yep.
And it's a question that I don't think I have a perfect answer to. I will say that we are working closely with students on making sure they have the AI skill sets. And this is the combination of the things that AI is not replacing, likely not going to be replacing anytime soon, which often involves both not just the hands-on experience, but sort of that intuition that that a good engineer develops, but also their comfort level with working in seamless partnership with AI as it continues to evolve. So that means their understanding of when to trust and when not to trust what the machine is saying, their understanding of how to get the best answers possible, and when to trust themselves and their own skills in the right time and in the right level of partnership. And what we're seeing and what we're hearing is that this is what people are looking for now. But the companies themselves don't know if what they're looking for now is what they're going to be looking for a year from now or 2 years from now, as everybody is dealing with this evolution of the technology. And we're starting to see where both new opportunities also, but where some inherent limitations might be. I'm going to remind everybody too that we are still waiting, like the AI business model itself has not really shaken out. And so the true cost of AI to citizens and to companies and to universities is not fully known, and there's still a lot of problems that need to get solved. But we're trying to make sure that we're preparing our students to be able to handle it in any possible combination that we end up with.
Good. I will continue to ask the questions in the chat if that's helpful for everyone, whether you're looking at your screen or not, if this is helpful. Our next question is, how are you working on scaling the Mind's processes to match with the current size of the university without sacrificing student experience, which is such a critical part of the whole, Mind's experience, is the student component of that. But do you have some comments in that area?
Sure. In some ways, I can say that's actually kind of a good news thing, because as we scale the Mind's processes, we actually free up more time and more bandwidth to support the student experiences. Because what's happened right now, I'm going to use one of my favorite analogies. This is something that I saw frequently, and I'll give you a specific example of a company out in the Silicon Valley area that I visited a few years ago, and they were about 200 people strong. But one of the things they mentioned was that the president of that company was still the only person who gave IT accounts out to all new employees as they hired them. And they knew it wasn't efficient. They knew that they needed to do something differently, but they didn't have time. They just had to keep doing what they were doing to keep up with the growth. And they kept saying, at some point, we're going to catch our breath and we're going to reorganize so that we're actually have the right people doing the right jobs. Right now, because we haven't scaled appropriately, we're kind of like that company. We have a lot of people doing multiple jobs, and we're kind of very thin and fragile in some areas. We maybe have too many people doing the same thing in other areas. I actually sincerely believe that just stopping and kind of restructuring how we do some of our processes at the right scale for what we're doing will actually free up more bandwidth and more time. And allow us to be stronger on supporting the students. So that's that's actually something I'm kind of excited about. It's easier said than done because you got to dig in and you got to really look at how we're doing different things and why we may be taking 3 or 4 times longer than we need to get certain things done. But I think everything feels imminently solvable. It's just a little tangled up.
Okay, I'm going to skip down here. Thank you to Nekmetin Setin, who's joining us from Turkey. I think you win the prize for the farthest, participant. That's awesome. I know you've joined us before, so welcome back. And he shares his congrats to you, Dr. Tompkins. That's very cool.
Yeah.
Okay, let's move along. There's a few more questions. We have some time left here, so let's try to get to everybody. Carrie Middleton has got a question. Carrie, would you like to ask it? It's directed toward me, so not everyone can see it, but if you'd rather say it, feel free, or I'm happy to read it. She might be muted at the moment, so I'll just read it. Her question is there a nexus between critical minerals and the new quantum campus that's going up North Arvada?
Yeah, so we have this amazing quantum commons that's up in Arvada, just up the street from where I live. Actually, it's a great location. There's not an immediate nexus, in the sense that these projects are evolving somewhat independently, but they are ultimately connected because the supply chain, critical minerals, a lot of these, there are the underlying elements of what will allow quantum to scale and to move towards like successful economic development. Right. So, as an example, in my DARPA job, we spent a lot of time looking at quantum computers. And for those of you that don't think about quantum, you might be surprised to know that the jury is still completely out as to whether quantum computers will completely revolutionize the world or they will end up being basically useless, other than as interesting scientific machines. Right. And so if you ask a number of physicists, you're going to get people passionately on both sides. And so one of the things we set out to do was try to benchmark quantum computer development. And a lot of the questions we found ourselves having to ask, that a lot of the companies that were building these quantum computer designs, there's a lot of different ways to build a quantum computer. So these companies were not asking or thinking about was the supply chain. And critical minerals play a pretty incredible role in some of these designs. And a lot of people had not realized that you might take, most of the resources currently available on the planet of a certain type of mineral or a certain element that in order to build the thing that they were building at a scale that would actually be useful, right? So it's great in the laboratory and they have all that they need. They had never thought about what happens when they scale up. And so we thought about that a lot, and critical minerals critical minerals and just basically other raw materials play a pretty profound role in our ability to have certain elements of the quantum revolution that people are imagining.
Good to know. Thank you. Melanie Westergaard, I see your question here. Do you want to open your mic and ask it, Melanie?
Sure. I can do that much.
Great.
I can't share my
Yeah.
screen, do anything else.
Okay. Hey, good to see
So
you.
Stefanie, hey, welcome, and great to have you. And my question really was around just get simple numbers of what is the count for faculty these days, and how many do we bring on board in 2025?
Yeah.
I know there's a lot of pressure from a lot of things. Golden is expensive. Can you speak to any issues around that, or is it just that Mines is such a desirable place, people make it work out?
Yeah, so the total size of the faculty, that count is always hard to pin down because it depends on how you define it. But if we think about all of our tenure track teaching faculty, it's about 350, I believe. And typically, in a normal year, we would be hiring, sort of 20 to high 20s. Last year, you probably know we were in a hiring freeze this past spring because of all of the things that were happening with research funding and elsewhere. So we only brought on 5 brand new faculty in the spring. The number sort of ends up counting as 7 because we had a few people that trickled in early in the year, and whether you count them with last year or this year is just more a matter of how you would where you draw the line. And so one of the things I keep reminding him is how extraordinary they are, that given the restrictions we put on it, we really, really wanted them, and we brought them in. Yeah, it's a balance. The cost of living continues to grow, and it is something we are constantly thinking about because it impacts how we manage our budget and our resources and how we compete. People really do want to come to Colorado. Golden is pretty amazing. Mines itself is just a huge attraction because of the students and because of the university, but people also have to be realistic. And so it's pretty dynamic, and we don't have a magic formula that we have found that, you know, sort of solves that problem. And so we're trying to understand what it is for any given person we're bringing on. What are the pressures and what are the things that drive them and would get them to a yes, and then we sort of customize around that as best we can. Yeah.
Thank you.
Kenny Hora is on the call. Hey, Kenny. Are you there?
Hi, Ruth.
How's it going?
Oh,
Good. How are you?
I'm great. Hey, do you want to ask your question so everybody can hear you and see you? And that would be great.
Yeah, can do. Dr. Tompkins, I was just wondering what steps your office is taking alongside RTT to help ensure that university research remains strong, especially given the uncertainty in funding from the federal government, in addition to it being difficult for international students with visas to travel to international conferences to present their research kind of to the world.
yeah, that's a lot of there's a lot of answers kind of packed into that question, Kenny. Let me focus on some of the really big picture things. So when we talk about the uncertainty in federal funding, there's sort of two elements of that. One is the changing in the rules around overhead rates. You know, essentially how much of our overhead costs will actually be reimbursed, because that impacts our entire financial model and obviously is impacting universities across the board. And then the other is the actual cuts to the research budgets of the funding agencies themselves. So, and the National Science Foundation taking a hit, or the Department of Energy taking a hit. So the volume of dollars is a concern, and then also that reimbursement of actual overhead costs. That's like, you know, the buildings and the power and the people who write contracts and things like that. Those are both at play, and we have been doing a lot of modeling and simulation to work through a bunch of different scenarios, and essentially have in place, you know, kind of a stepwise plan that sort of says, if this particular thing happens, then we enact this next step. And some of that has to do with how we redistribute and share some of the overhead returns back to campus. We have preferred to allow a lot of it to be held at, say, the RTT office level, because they can then invest in larger things than any faculty member can by themselves. That distribution model might have to adjust, because some of that money has to go into actually paying some of the bills that won't get paid with the reduced rates. When it comes to the lower volume, I mean, I worry, but I worry a little less, because the things that the government continues to want to invest more in are exactly things like critical minerals, quantum, and energy, and those are areas that Mines faculty are continuing to do really well in. Yeah, I'm not saying that it won't have an impact. It absolutely will, but a lot of what we're doing is using this opportunity to sit down and think through, you know, kind of clean sheet of paper. What should the research world look like? You know, let's free ourselves from how it's always worked for the last 3 or 4 decades, and let's imagine how you would want it. We would love to not just continue, but strengthen our industry research. And I think there's a lot of opportunities to sort of reimagine how we would structure ourselves and take advantage of this time to think about how we might implement that if some of these changes in the overall science and technology community continue to play out.
Awesome. I see a question here from Daniel, and I think, is that you, Dan Witkowski? There might be another Daniel on the call, but and Stefanie, I think you've touched on some of these topics in your answer just now, but you know, given that these stops and starts will happen, you know, how are we handling that? when the research work has deadlines to keep funding, but yet students need to make their way through them in order to graduate on time. So I think you've kind of walked through some of that, but do you have any additional comments to that question?
Yeah, I mean, I will say that we never expected to have the luxury of just bringing everything to a halt. Uh,
Mhm.
it is not, we're building the airplane is in the air. But maybe what's nice is that while the airplane is in the air, we're not actually making the airplane bigger. We're just, this is when I say that we're sort of stopping to catch our breath, what I mean is that we are not actively growing and having to dynamically change to yet sort of continuing new situations in that pool. Now, AI, it will continue to put a lot of pressure and challenge and keep our imagination sharpened in in the fact that we can't come to a halt because the world is changing there. And certainly some of these other things that are happening geopolitically and around the world are putting pressure. But when you sort of know how big you are, that is a huge variable that you can sort of fix. And then that allows us to do a lot of process engineering that should not get in the way of our students, and in fact, should gradually make their lives easier. I will say right now, our process for undergraduate hiring, for hiring students as workers, is just crazy hard. And I don't know if we could have designed a more complicated one if we had tried. We just sort of evolved to that. Just making that simpler would free up everybody's time, the students and the administrators and the professors, all of the above. So we're looking for things like that early on in order to give people a little more breathing room. And then we tackle the more complicated ones as we go.
Very good. I've got a few more questions here sitting in the chat that we will address. We've just got a few more minutes before we wrap up. So in the interest of time, let's just dig in. This next question is from Steve James. Hi, Steve. Do you want to unmute and ask your question?
Well, I think Dr. Tompkins has answered most of it in discussing some of the previous ones. So let me focus on just the very end of it and amplify that quickly. When I went to school at Mines and in graduate school, I had the luxury of some professors who were extremely good at attracting industrial funding. And essentially all of their graduate work was funded by private industry as opposed to federal institutions. But I've perceived a shift over the last 20 years to reliance on that. And I've also suspect in my conversations that some of the professors just aren't that good at being able to interest industry into supporting students. So the question is, and you brought that up, is have you thought about what processes we can employ at Mines to get our faculty to get in tune to this new funding reality that we're going to be facing for a while?
Yeah, absolutely. We think about this all the time. And one thing I will say is that when you look at absolute numbers, interestingly, I don't think that our industrial focused research has really changed that much. It's just that the pie has gotten bigger. And as the pie got bigger, it filled with the federal research. But I worried about this too. Actually, when I was at DARPA and I was looking back at what was happening, I was both impressed by the growth at Mines, but I was also a little worried that as new people come in and some of our older faculty retire, we might be losing that experience base. So, among the things we're talking about are, how do you provide more senior level support to those industry engagements, right? This is, in some cases, there's kind of two levels you do it. One is this very decentralized individual professors or a few professors together engaging with industry on a certain problem and then developing that relationship. But also there's a lot more strategic level partnerships that we can do, and we can actually look at a range of ways in which we can provide support, whether it's maybe collective consulting on questions, because industry is facing lots of complicated questions as well. And our faculty, if you bring the right mixture together at the right time, can help in ways that no one of them individually could do. So we're exploring a lot of ways of trying to, I think, scale up some of that industrial support and adapt to the kinds of help that we think industry is likely to need. And industry has evolved as well, right? And so there was a time when much more internal advanced R&D happening. And now a lot of that is sort of outsourced in different ways. And so we're looking for different models by which mines could start to partner much more to fill in the gaps that have also occurred on the industry side.
Okay. We have 1 minute to go. I've got one question sitting in the chat, so let's do it and then we'll wrap. Let me just chime in very quickly for everybody who's still with us. A plug for next month's program very quickly. Will be on Thursday, October 16th. If you haven't signed up, please do on our website. We'll be hearing from Dr. Carl Frick, who formerly was head of the mechanical engineering department, who now heads up our graduate studies program. So I know there's a lot of alums on the call today who also, in addition to having your undergrad degree from Mines, or maybe not, you may also then have a graduate level degree from Mines. So things have changed, things are growing, and Dr. Frick can certainly give us the inside scoop on that. So please be sure to mark your calendars, join us. And let's see, let me make sure I say this right. Okay, how will Mines continue to support and retain professors and the diversity of higher level courses with the decrease in federal funding? I know we've kind of bounced all over, but I want to make sure that I address everybody's question.
Well, that actually was incredibly timely, because the short answer to my question is you should probably listen to Carl Frick next.
There you go. Perfect segue.
A significant part of his job has to do with certain categories of degree programs that actually ultimately support the university financially in ways, so we don't have to put the tuition burden on undergraduates, for example.
Sure.
And so that is one of the things that's top of mind for him. But in general, I will say this is the thing that I live and breathe every day, is making sure that we support our really amazing faculty. They are why I came back, both through this time of uncertainty and also like in terms of envisioning what it looks like on the other side and having it be something that they are passionate about and want to be part of. And there's a lot of different levers that we're sort of pulling and playing with at the same time. So all I would say is we're in the middle of a lot of sausage making, and we're figuring it out, but it is probably the single if you take all the other stuff we're worrying about together and collapse it in, you've sort of asked the question that pulls it all together.
And that's why we do Lunch Bunch, right? So you all can see how the sausage is made, right? An insider scoop to all the things, all the great things that are happening here. Thank you so much. And Melanie Westergaard, I see you on my screen. You want to give a little news flash update promotion before we say goodbye?
I'm so glad you asked, Ruth. I'm chair of the Mines Alumni Board, and I just wanted to put also a plug in there for homecoming coming up next month. October 2nd, there is a Mines Fall Festival from 3 to 5 in Stratton Commons, Cadaver Commons. And there's an all alumni night at New Terrain, which is a brewing company at 44th and McIntyre that is owned by Mines alums. So come to that. That is at 5 to 7 on Friday night. And then the bonfire lighting is after that from 7 to 9 in Q Lot. On Saturday morning, there's obviously the 5K. There's a lot going on that morning. There's also a tailgate at the Labriola Innovation Hub complex, which is a fantastic place for a tailgate for alumni as well before the football game. That starts at 12. The tailgate starts at 10. So a.m., by the way. So don't be late. Be there or be an octagon.
Excellent. All right,
Thanks.
y'all. This was great. Stefanie, thank you so much for your time. It's a busy part of the semester as things are getting traction and getting rolling, and we're going to blink and it'll be Christmas, right? Don't even say that, but it's true. Things happen at a pretty quick clip around here, but we thank you for your time. A reminder again, this program has been recorded, and we will post it as soon as we make a few tweaks to it to our website, so you can listen again to review anything you might have missed. So anyway, that's all we've got for this month. Thank you for being awesome ore diggers, and we'll see you all next month. Take care. Bye-bye.